So my name's Jeff Smith. I'm with a company called QuantumIoT. We're an IoT systems integrator. I have a background in this space. I started a company called SensorLogic that was purchased by Gemalto. That was started about 15 years ago. Started another company called uBlip that was acquired by Numerex. Became the chief technology officer at Numerex for about 6.5 years. And then about 2 years ago started QuantumIoT. So Jeff Mucci asked me to speak on a couple of different topics. The third topic, it's Friday afternoon. There's a bar between here and 6th Street. And what I'm going to do is talk about software-defined WANs and in the context of real applications, if that's all right. And hopefully you'll get something out of it. We'll breeze through this material relatively quickly.
Could you talk about quantum?
I will. How about that? So what is quantum? Well, we're a systems integrator, I said, with a long tail. The long tail is basically a service provider. We have a full network operations center, 7x24, and do DevOps capabilities and hosting of IoT applications in addition to monitoring the networks and doing security. So it truly is an organization that goes end to end relative to the value chain in machine-to-machine and IoT applications. So at the bottom of the food chain, you have devices and sensors, and then cloud-based services and connectivity. We provide platform integration. Our platform, we call it the unplatform because basically the platform is a mashup of microservices that you can deploy on using OpenStack on AWS or Azure or Bluemix. And then we have applications that we've written for third parties in addition to having some applications of our own. And then we also do analytics. I did one presentation yesterday on machine learning. My background is I have a PhD in computer science. It's in artificial intelligence and robotics. And did a lot of stuff with neural networks on different types of pattern recognition and classification. And also, in my dissertation was a robot that learns how to fly. Won the first international flying robot competition. So I'm going to talk about a couple of different case studies, some by name, some I'm going to have to be a little bit more generic. The first one is a company called Catapult Health, of which the challenge there really was about from a network side, was really about how we integrate a lot of this technology together in a remote consultation with a network that has the ability to be able to be HIPAA compliant. And so there's lots of nuances about that, but in this particular application, we have a system that we developed that we call TopCat. All of the names of a lot of these things are named after Hanna-Barbera characters. TopCat is because of, you can see the little, that's not working, but, oops, forward. Let's see if this works. Nope. Oh, that didn't work. What did I do? Oh, now I'm in big trouble.
Yeah. Here we go.
Okay, here we go. Okay, in any case, I don't have a laser pointer, but if I were to point to something, on the left-hand side, you basically see a Pelican case. And what happens at Catapult is that every day, very early in the morning, a health technician, along with a few cohorts, go out to remote sites at businesses where they're going to do health checkups for those employees, health and wellness checkups for those employees. And you have to establish a network for a remote consultation, which is Oh, thanks very much. How about that? Remote consultation, and which button do you push? This one?
Top, middle.
Top, middle? No, the middle? Oh, look at that. And so in any case, this actually is in a hospital where each of the employees of the hospital will go in during the day, sign up for one of these health consults. They'll basically go through, get their blood analyzed. The analysis of that blood will automatically go up to the cloud along with the biometric information and things like that. By the time you're finished with that 12-minute blood analysis, which is a portable device that's fully lab certified, that information gets processed in the cloud, and then you go over to a meeting with a televideo conference to a nurse practitioner that's located in San Antonio or Dallas. Here's the problem. The problem is that when you show up at these types of facilities, whether it's a manufacturing facility or a healthcare facility or anything else for these employees to go through this process, the problem is that You don't have any network connectivity. You have no idea. You can't use the Wi-Fi because it's probably have all kinds of things blocked, particularly video. And so what you really need to do is set up ad hoc networks. This occurs across the entire United States. And you're not sure where that, you know the location, but you haven't visited the site before you show up. And so it could be in a relatively poor connectivity area, and you're not really sure what coverage is by a particular carrier. So from a network standpoint, particularly from SD-WAN, this is probably one of the hardest edge cases in SD-WAN. So if you can solve this problem, you can solve just about any problem in SD-WAN. That's why it's a great use case. In this particular case, we have 3 different radios. You'll notice the colors down here match carriers. So each one of those radios actually maps to a particular carrier. And then what we've done is we've taken a off-the-shelf Linksys router. And if you're familiar with OpenWRT, it's really an open source software that goes into the router. And we basically wiped out the router, took OpenWRT, modified OpenWRT, and contributed back to the open source community to make the LAN ports into WAN ports. Okay, so in effect, what we've done is built an edge device, which is for a software-defined WAN. Okay, and then reprogrammed this device, and so it has different types of algorithms that we've been working with in order to optimize different connectivity options from a wide area networking standpoint through these different carriers right here. In order to have enough bandwidth to be able to do anywhere between 1 and 4 consultations around a laptop, which is in a video conferencing session, which requires about 800 kilobits per second. Okay? So, the second use case that I'm going to talk about is a company called Studio Movie Grill. There's actually one here in Austin. There's about 30 around the United States. They have about 10 theaters per Cineplex, and so you have 300 theaters. Now, interestingly enough, each one of those Cineplexes was originally, when we showed up, was on an MPLS network, which is pretty typical of a wide area networking implementation. MPLS is typically a network which has the capability of being relatively redundant. It has the capability to be able to be relatively cost-effective to some extent. But the challenge is that typically when you go to make a change from a wide area networking standpoint, it could take weeks before you get a modification from one of the carriers. In addition to the fact that you're basically up front, a priori, going back in and specifying what the bandwidth requirements for each one of these things. And when we came to the theaters, we found out that there was about 9 megabits per second to each one of the theaters, which wasn't nearly enough for what they wanted to do, which was they wanted to be able to do some downlink video conferencing-like presentations into the theaters for corporate events. And so we had to rethink that process because the theaters basically had about 4 different types of applications that were going on at once, in addition to lots of ideas of what they wanted to do in the future. And an example of that is PCI DSS. So in the theaters, they do transactions over the internet, and usually through the MPLS connection, through a gateway. The gateway goes to a PCI, through a credit card provider, through a PCI DSS connectivity that needs to be now compliant. Right? And so now you have all kinds of considerations relative to the other applications that you may run on that network. And other applications may be in a theater, you may want to go in and just hook up to the Wi-Fi because this particular theaters are not just theaters, they're also bars and restaurants. So this is the bar, restaurant, theater experience that is now quite popular with Barca loungers and things like that. And the idea is that you're going to provide an experience for your customer. Well, in addition to that, all of the information related to their point-of-sale terminals, of which there's 2 different kinds. One's for the theater, the other one's for the food and beverage. And then there's information that's going back because we had it set up a data lake for these folks with all this real-time information, including real-time information about transactions that are happening on the web online, another connectivity, and also inside the theater where you have IoT-like devices, like, for instance, switches that you press in order to ask for the waiter or waitress in order to come and deliver you your food or take an order. All that information goes through an IP connection, goes up into the web, and gets processed in the data lake, and then gets presented back to the manager in real time so that they can change different resourcing that's going on. And in addition to that, there's lots of automation that goes on, things like the theater being able to move from one place to the next. If they, in fact, sell out the seats, they want to put it into a larger theater. Well, in addition to the actual movie moving from one place to the other electronically, because it's a digital movie, you also have to change the Dolby sound. You have to change usually the size of the screen. You have to change the air conditioning depending on the number of people that are in there, and various other things. And the sound, the Dolby sound. So in this particular challenge then, the software-defined network has at least 4 different applications of which you want to basically be able to do tuning of each of those different network elements, applications based on the quality of service or the security mechanism or things like that. So how do you solve that problem? Well, that problem is an SD-WAN problem where you eliminate the MPLS network, and they're in the middle of doing this, where you put some intelligent edge devices around the perimeter in each of the theaters, in each of the, cineplexes, and those, instead of going back through an MPLS connection, are then connected both through the internet, sometimes through a redundant internet connection, that'll be 2 connections, and then a third connection, which is an LTE WAN connection. So now you have a similar sort of architecture that's starting to evolve, where you have this software-defined architecture with in-node intelligence, where the architecture really includes both a wide area networking component through an LTE provider or multiple LTE providers like using the TopCat, a local area, not local area, but a internet service provider local to the area, which may be Comcast or a cable provider, and possibly a backup for that. And then combining each of those different ones into a more reliable connection than having any one separately. So why SD-WAN? Networks use application-based routing instead of packet-based routing. Businesses can rely on consumer-quality internet, which is less expensive than a private network. But you'll be able to do it with improved performance because you have redundancy. And then you provide, from that, you can provide significant cost savings compared to a multi-protocol label switching MPLS circuit, which is typically used. And that's why it's becoming so popularized nowadays. So why SD-WAN? Capacity to scale quickly and almost ad hoc. You can change and tune the parameters around your network, in fact, through a single user interface. Improve reliability, because there's a hybrid nature of this with multiple providers. Simplified network management. Path selection and failover automatically, so you can do rule-based routing based on the application and based on the quality of service that you're getting out of those particular network elements that you're using, and you can do that dynamically, which allows you to improve your link quality, ability to route high-priority applications through optimal path, and high priority may be, for instance, voice over IP. Real-time packet level monitoring, and the ability, and because you don't get that kind of visibility from your MPLS provider for sure, and the ability to turn your broadband connection into a fast and secure connection on the internet. To give you an idea, just pictorially, I ripped this off from one of my cohorts, and basically on the left-hand side is a typical MPLS network. You can tell that the intelligence is in the network itself. The MPLS network routing is based on an IP protocol routing, versus on the right-hand side where you have wireless, you have internet, you have different, and you can even have an MPLS connection in a hybrid nature on the right-hand side. But notice the connectivity and the intelligence is actually at the edge rather than in the center of the network. So a little bit deeper in here is that the orchestration is really done through a common portal, which is done through Network Provider, which is a service that we provide. And then within the internet, you basically have the opportunity to be able to go through that, to be able to get to any one of the edge nodes, to be able to manage those remotely and all through the single portal. Now, what's going on, and one of the things that's driving this, is the fact that applications are really moving into the cloud. And there are different applications for different cloud providers. And so one of the things that you'll find that's going on within the folks that are serving the networks is they're trying to not lose this revenue. Because if the revenue ends up going to third-party providers instead of the folks that are providing the network, like AT&T and others, then that's a problem because they start losing revenue. So how do they lock you in as a customer? Because they can't lock you in as an MPLS customer, so they have to provide some other value-added service. And what that value-added service is that they're now getting dedicated connections between themselves and some of the drop-off points with Google AWS and some of the other hosting providers like Azure and others that are providing some of those application services. So if your email is hosted on Microsoft 365, then you will, and AT&T goes to you and says, oh boy, you don't want to be on that nefarious internet thing. You want a connection with us because we're going to drop your packets off and it won't go through the internet. It'll go off on this drop-off point that's located at an exasite facility that has a direct connection into AWS or to Google. Okay, so if you're using Google applications or you're using Microsoft applications, it's going to be dropped off on a private network to them. So that's the argument you're going to see a lot going on in order to sort of hold themselves onto those types of customers. The problem with that argument, though, is that with IPsec and others, you have the ability, and particularly things like the HTTPS and other security protocols, you have the opportunity to be able to create at the application layer as secure a connection as you could through a VPN that you had done before or through an MPLS connection. And you could probably make the argument even that it's more secure than some of the MPLS connections that have been compromised in the last few years. So within that, a hybrid network will probably exist. But I think over time what you'll find, particularly because the security protocol is in place, particularly because the economics are working in that favor, and particularly because the drop-off points will in fact be the same drop-off points that you are with your service providers, either from an LTE standpoint or from an IP standpoint with things like cable providers and DSL providers. It's going to be kind of a wash, but economically it'll be more beneficial to move toward an SD-WAN. So WAN needs, I want to make sure my WAN cloud's easier to manage. I want to be able to do SLAs on jitter and latency and those kinds of things with voice over IP. What happens if the cellular network is fantastic and my internal network really is terrible? Well, if that issue is, I want to be able to fail over to the LTE network, and it'll get better with 5G as we move into higher bandwidth capabilities. I really want cloud drop-off points. I want performance and security. And I got to be careful because really what I want to do is have a fully managed service, so I don't want to worry about the endpoints. I'll pay a fee for people to be able to manage those endpoints themselves. And who owns it, IT or OT? You've got that problem that people have talked a lot about. There's really no personnel on site, and so I want to be able to do remote management, particularly for locations where you don't have anyone that has that level of capability. I need high availability with wireless backup. There's a lot of that going on, particularly in the IoT space, and I want to move secure to the edge and centralized office for VPNs. So more traffic is internet-based. And productivity tools like Microsoft 365 and Google Docs are well being used now from service providers and even Amazon, AWS, and Microsoft Azure. And so what I want to be able to do is I want to be able to use those applications but to my network in such a way from a security and a protocol standpoint to be able to optimize both the cost and the types of bandwidth in those, and I want to do that dynamically. So here's, I provide this in my presentation at your leisure to be able to go through and look at the different types of folks that are providing this type of technology. One is they're like folks like Cisco, for instance, are providing it as a box. And then you can go manage it yourself. Or in some cases, they're providing a cloud-based delivery of an SD-WAN capability, or in some cases, it's a managed service, like for instance, the kind of capabilities that QuantumIoT provides.
What was the one at the bottom?
VeloCloud or via Talo. Yeah. Yep. Okay, so 3 different types of infrastructure hosting requirements, really, from a content standpoint. The first one is the delivery of static content to end users from a distributed solution standpoint. This is pretty common. You've got a website. You got a bunch of content that's in the website. Depending on how much the utilization is of that, you may distribute it yourself, host it someplace in the cloud, and be able to provide connectivity to that. Or if you have a content delivery system, because you have a lot of streaming content and things like that, you probably have a CDN provider. So within that, that's one of the types of of information that you want to be able to have access within your network now. And that's probably in a hosted cloud, but you want to be able to have some level of control over the access to that. The second one is data ingesters. So from an ingestion solution, you might be, this is the M2M IoT sort of stuff. So from an ingestion standpoint, you have a lot of things that may come at spiky intervals. And so how are you going to ingest that? Well, there's ingestion engines that are now available from many of the cloud providers or infrastructure providers like AWS. So the opportunity there is to be able to host that within their facilities, use their ingestion engines so that you don't have to have all the infrastructure to be able to do that, and you don't have to bring that data inside your firewall. So from a security standpoint, you can use their and use software-defined WAN in order to have policies to be able to prevent that information from getting into your systems. And then the last one is application and content origination, which is where the core of the applications that you have are and where they run. Typically now they're in AWS and other infrastructure providers from a hosted facility standpoint. So the question is when you define an SD-WAN, is that how do you take an architecture that takes into consideration each of these three different types of infrastructure hosting requirements and the SLAs that go along with them. And that is the end of my presentation, if there's any questions. Okay. Thanks very much, and I'll see you at the bar.
Questions?
Anybody? Questions?
Yeah, you listed a host of SD-WAN providers. Do you work with any of them? Or?
No.
No?
No. We don't. We don't. We provided ourselves and some of the equipment, like I had shown, we've developed ourselves internally, and we used, off-the-shelf edge equipment. I can give you another example of another one that kind of really defines this idea, and that is that if you look at C-stores and gas stations and things like this, they have a requirement for, and anybody that really does point-of-sale type stuff, they have a requirement to be able to do transaction processing, and it has to work. Well, the other thing about it is it has to be PCI DSS compliant. So if you think about it, that's like worst-case scenario of a business, because you've got a 1,000 stores, right, that are doing these transactions, much of which the folks that are inside the stores, so for instance, the energy management company or the company that does the gas pumps or the company that's doing the transaction processing or the alarm company, all of those are different folks, but they all want the same connectivity. So how do you isolate them from each other and you still can follow and comply with PCI DSS? It's a very complex problem. Well, it's not as complex anymore because now you can buy devices from folks like Cisco and other Cyberra and Acumera and folks like that basically what they've done is they've taken a router, okay, and now they've made on the back, instead of having pretty conventional WAN ports with routing protocols that are basically built into them, they basically made them VLANs, okay? And so now the problem, the next evolution of that, because before what happened was now you had a VPN that was basically connecting to each one of those, right? And you can imagine if you had several hundred stores, okay, you're going to have several hundred VPNs that you need to manage. Now, you also are going to have to be PCI DSS compliant. And so when you do that, you're going to have, it's not statistical when you do it that way. They check every one of those freaking connections, right, to make sure that they're all in compliance. You can imagine the management of that would be a freaking nightmare. And so the opportunity to be able to IPsec protocol within a conventional WAN-based connection that just basically goes to the internet, now you have this distributed capability where they're all configured exactly the same, and the connectivity requirements in PCI DSS is basically to that edge of the internet, not necessarily through your entire MPLS network or through some huge mishmash of VPNs that go to a centralized location. Okay, so the complexity with which you're now managing in order to become compliant with some of these new regulations is a whole lot less to manage in that scenario. And that scenario plays itself out in retail and food service and all sorts of other ones where you have lots of different individual boxes that are out there in the Never Land that need to be connected, in addition to the fact that it's also international. And you think about the additional complexity from an international standpoint is that now you've got, particularly in Europe, you have all kinds of requirements where the data, because of privacy concerns, has to be kept within geographic borders. Okay, well, if data has to become, within geographic borders, how do you do that? How do you manage that remotely and things like that? You're not going to do that through conventional, and you're not going to get there through MPLS because it's just too damned expensive from an international standpoint. You're going to do it through the conventional internet. So now you have to manage something at the edge that's through a conventional internet circuit. Okay, that is not easy to do unless you have intelligent edge capability that's at the application layer from the point of view of routing the protocol rather than the IP layer. Any other questions? God bless you.
Doesn't keeping it in region still require layer 2, layer 3 control?
It does.
It does.
Yep.
So how do you enforce that through a third-party ISP?
Through the edge, at the edge, before it gets there, right? Locally. Yep. And the nice thing about some of the cloud providers and infrastructure providers is that they're now providing those in their data centers that are in country, right?
So do you encapsulate it? How do you control it at the edge?
No, you control at the edge at the application layer. Okay. Yeah, you move up. Yeah. Okay, thanks very much.